This is lesson 4, good vibrations. So sounds are made when, so you need an object to vibrate. So in this case, you need the violin strings to vibrate. You need the skin of the drum to vibrate. You need the tuning fork prongs to vibrate, or you need the cone inside the loudspeaker in here will vibrate in and out to create a sound. And so when an object vibrates, so an object vibrates. And so we've already spoken about this, what vibrates, so the following make the sounds. The violin strings. Now, also when the violin strings vibrate, they cause the air inside the sound box of the violin to vibrate, and that's what gives the distinctive sound of the violin. And that depends on the type of material that the actual violin is made from. If it's made from wood, or what kind of wood, or how old the wood is, you'll get a different sound. The skin of the drum vibrates. The loudspeaker cone, which is in here, this case shows a man singing, and it's his voice box in his throat which vibrates. And all our voice boxes vibrate to create sound, and that will obviously cause different sounds of our voices. So how does sound travel? So we've already mentioned this a little bit too. Sound travels from the source of sound to your ear. And sound travels as a longitudinal wave, so it travels as a series of compressions and rarefactions. And the compressions are where the sound waves are close together, and the rarefactions are where they are far apart. And those sound waves are causing compressions in the air molecules between the sound and your ear, and that causes the skin of your eardrum to vibrate and causes then a signal in your brain. The compression and stretching of air particles creates a sound wave which is carried to your ear. And so if I just focus in on this a little bit more, you can see here these are meant to be sound particles, or particles of air. And you can see here this is the source of the sound in the centre, which is causing a vibration. And it causes air particles to move in and out. So this is a continuous sound, and you get these regions then of compressions. In between you get rarefactions, compressions, rarefactions, and that is how the sound is travelling out to your ear. So we just scan out again. Now, how does sound travel? Well, sound travels through materials, and sound needs particles to travel through because it causes vibrations of particles, and that's how the sound travels from one place to another. The bell jar experiment is an experiment you need to know, and it's one that we do in the lab. And what you have is a glass container, and inside there's an electric bell. This just shows a little alarm clock, but there's an electric bell. When you connect a vacuum pump to it, you suck the air out of it. So when there is air in the jar, you can hear the sound and you can see the bell ringing. Whenever you suck the air out of it, you can still see the bell ringing, but you can't hear it anymore. So whenever you remove the sound from the bell jar, you can't hear the bell anymore. And the reason is, even though it's still ringing, sound needs a medium or particles. Not necessarily air, because you know that sound can travel through all different types of solids. So it doesn't have to be air, it just needs to be particles. So if you had this bell and you set it onto the base of the jar, you might hear the sound then, even if there's no air in the jar, because if it causes the base to vibrate, then you might hear the sound coming through the base of the jar. But when we just remove the air inside the jar, you can't hear the sound if it's just hanging there. And the one that we had was just hanging inside. Right, sound through other materials. Does sound travel through? So does it travel through a gas? Yes, obviously, because we can hear sounds through air. Does it travel through liquids? The answer is yes again, because you can hear sounds when you're underwater. You can hear them in the swimming pool, hear all the sounds above you. And does sound travel through solids? Yes, of course it does. You can hear someone knocking on the door. You can hear sounds outside the room, and obviously the sounds travelling through a solid to get to you.